So we're going to go through half angle identities. And so the basic, we've done double angle, we've done our regular angle, that's what we started with. So these formulas look pretty crazy for sine and cosine. So we'll walk through it a little bit, but fear not, these are given to us, okay? And the biggest problem sometimes with these is just kind of working with the formula and the computation of the numbers. And so basically how this formula works, the problems that we're going to do are, we're basically plugging numbers in and cranking stuff out. But the idea is if I want sine of 15 degrees, that's a hard angle to work with, right? But sine of 15 is the same as sine of 30 degrees divided by 2. So I can use this for that guy right there, and I take the 30 degrees, I plug it in here, and then I evaluate what I got, right? What's cosine of 30 degrees? It's root 3 over 2, and then I'd start working with it, okay? And so that's the basic idea of these formulas. The one piece that we got to work on, though, is, or talk about, is this plus or minus. And the plus or minus is based on where the half angle is. Okay, so that's important. We'll talk about that in our next example. But these are the formulas. Make sure you jot them down. We're going to go ahead and use those going forward. And these will be given to you.
128 hours.
Mr. Allen's talking numbers here. 128 hours? Yeah? Are those numbers too large for you, Mr. Allen?
Can't handle that much math.
So what we have here is we have our cosine of theta, and that's what we're finding. Okay, we're given a sine function, and we're also given this right here. This is where our angle is. So the first thing I'm going to do is I'm going to write down my formula, and I know I'm going to be using the cosine of theta over 2, which is equal to plus or minus the square root of 1 plus cosine of theta, all divided by 2. Okay, so how about this plus or minus? So which one? So here's my work for the plus or minus. Where is the half angle? I take my range for theta, and because we're dealing with a half angle, I divide everything by 2. So if the original angle is between 180 and 270, I take halves of everything, and I get my half angle, right? If I divide an angle by 2, it's going to get smaller. What quadrant is it now in? So this is a second quadrant angle. We're dealing with cosine, so that means I'm going to apply the negative. Okay. So the second part is, within the formula, it's asking for cosine of the angle. Well, I'm given sine. So what I'm going to do now, this is where it gets a little tricky. The original angle, theta, is in quadrant 3. So I'm going to go ahead and draw my triangle where theta is, because that's in the third quadrant. Pythagorean theorem would give me my x values, so this is equal to the square root of 5. Okay, so now I know that I'm using the minus in the formula. I know that cosine can be obtained from using this triangle, and I'm going to apply everything and plug it into my formula. And this is a multi-step problem that's got some stuff. Hey, good morning. We got a student walking in while I'm making a video. Good morning, Anthony. It's wonderful to see you. That's quite all right. No big deal. Anthony's a nice guy. Don't worry about it, kids. So then I'm going to go ahead and plug in my trig value and work with the problem. So I know the formula is going to be a minus 1 plus cosine of theta, all divided by 2. I go revert back to my triangle right here, and I know cosine's negative root 5 over 3, and so I plug that in. All over 2. So now this is messy. Messy, messy, messy. So we got to be careful with this. So the first thing that we're going to do is we're going to walk through this step by step, okay? First thing I generally do with these problems, because we got the embedded square root, is I'm going to go ahead and simplify the numerator first. And just to kind of over-exaggerate what's going on right here, I'm going to take, well, we got the negative out front, right? And so I got my negative out front. I'm going to put this big old square root. And then just to kind of focus on the fact that the big outside square root doesn't really matter. And I'm going to go ahead and just write it like this. Okay. So I don't know what's going to be easier for most of you, but I know that if I'm dividing by a number, that's the same as multiplying by its fraction, right? So that means if I divide by 2, that's the same as multiplying by a half. So I'm going to go ahead and put the negative out in the front, and I'm going to put 1 minus root 5 over 3 times 1/2. And Mr. Dickens trying to break my concentration at work. I have no idea what he's talking about here. So he's got some phenomenal music playing in the background. And for those of you who maybe like this music, hopefully you're turning the volume down for your parents. So, anywho, so this is one way of doing it, and I'm just going to distribute the 1/2, and this might make, life kind of easy. And I get negative square root of 1/2 minus root 5 over 6, but I need to get a common denominator now, and so I'm going to multiply this half by a 3 over 3, because I want to write it as one term. So I get the negative out here, and I have 3/6 minus root 5 over 6. And so this whole fraction within the fraction thing, too, is kind of confusing, the amazing music that we just got to the pleasure of listening to. And then now that we have fractions that are the same, it's 3 minus the square root of 5 all over 6. And this bigger outside square root we don't do anything with, okay? So this is where the problems become difficult. It's not putting the pieces together. It's working with that, once we've plugged everything in, working with some of these crazy numbers. Okay, so half-angle formulas, the formulas themselves will be given to you. You just need to know how to work with them.